Now I think we can find some of the examples of components. We have X defined in this way. X is this set, this set, that set. We want to find the components of X. Recall that we defined the previous session. We define a component of X as a subset of X which is connected. Subset of X which is connected. So A is a subset of X, A connected. Then A is a component of X if there exists no connected subspace of X containing A. If there exists no connected subspace of X containing X. And we also had our relation defined on a set. We say that two elements in that set, they are related if there exists a connected subspace, containing X and Y. X is related to Y if there exists a connected subspace of X containing X and Y. If there exists a connected subspace of X containing X and Y, and this relation induces equivalence classes known as components. So we are going to first ask ourselves what a component is. We know now what a component is. It has to be a subset of X. So this is our X. So let us start with the simple ones. Let us start with this set. Observe that this is a subset of X. It's a subset of X. Then it has to be connected. This interval here is connected. Connected subset of a real line, or is take this form. So this is connected. It's connected. Then we have to make sure that there is no connected subspace of X containing this set. Observe that there exists no connected subspace. There exists no connected subspace of X containing -2, 0. Observe that there exists no connected subspace of X containing this. Now, I want you to actually believe this. Observe that this is a subspace of X. This is a subspace of X. But it does not contain this. And this is not connected. I'm just trying to check and convince myself. I'm trying to convince myself that we have no connected subspace of X containing this interval. So this does not contain this interval. Similarly, also this is a subspace of X. It contains this interval, but it is not connected. This is not connected. Why is it not connected? This set and this, they have no point in common. This is connected and this is connected, but the union is not necessarily open. The union becomes open if and only if this has a point which is common here, or if this has a point, that point must also be common there. So this is not connected, however it contains that, so that disqualifies this to be a set containing this, such that this set is connected. So that implies that we have no connected subspace of this set containing this. We cannot construct such a set. We have tried to check these options, this and this. This doesn't contain this. Also this, it contains that interval, but it's not connected. This is not connected. So we can actually conclude that this is a component. So negative 2, 0 is a component. Similarly, following the same argument, 1, 3 is also a component. Is also a component. 4, 5 is also a component. Now those are the obvious cases. Now, what if, let us ask ourselves, is I'm just trying to consider something which is arbitrary. Is negative 1, 0 a component of x? Is it a component of x? Is it a component of x? What makes it to be a component? First, it has to be connected. Observe that this interval, that open interval is connected. It's connected here. It qualifies to be a connected subspace of x. It is connected. Then there exists no connected subspace of x containing that set. So we have to make sure that we have no connected subspace of x containing that. Observe that negative 1, 0 is contained in the connected subspace. The connected subspace, this one. Observe that this is a subset of that. So this set is not a maximal connected subspace of x. So it's not a component. Similarly, 2, 3 is not a component. So this is not a component. Negative 1, 0 is not a component. Now let us ask ourselves, what about, let me consider a point here and also a point in here. For example, is negative 1, 2 a component of x? Is it a component of x? First, it has to be connected, and you all agree with me that this is connected. Yes, it's connected. Then there exists, we have to make sure that there exists no connected subspace of x. There exists no connected subspace of x containing this. So we have to ask ourselves is there exists, are we having no connected subspace of x containing that set? It's actually a difficult question, but let us first sketch something. Let us first make use of a diagram. Then we can actually see what this is. We have x. X is defined in this way. We have negative 2. Then we have 0. We have 1. we have 3, we have 4, we have 5. So this is have that. Then we also have this. Then you have this. X is the union of this plus this plus this. Now we are asking ourselves, is this a component? We have -1. -1 is in there. Then 2 is here. 2 is there. Now is the interval -1 to a component? First of all, for it to qualify as a component, we have to make sure that it's connected. But is that thing connected? Is it a connected subspace of X? We have to ask ourselves, is it a connected subspace of X? Because X is the union of this set, which I can call A, B, C. And you realize that A, B, and C, they are disjoint. They are disjoint. They are actually forming a union of X. A, B, and C are disjoint. So it's like within X we have a separation. So X is not connected. So is this interval -1 to 2 connected? Is it a connected subspace of this X? We have to ask ourselves, is it a connected subspace of this X? Is this interval connected? Here, is it connected? Is it connected? At first we had this. Observe that this was connected because for it only lies here. -1 of 0. It is within there. So for it it's connected. But X defined in this way, informs us that actually -1, 2 is not connected. Because this set and this, they are disjoint, also C is disjoint. So it's like -1 is not related to 2. You remember our relation which we defined. We defined that relation in such a way that 2 elements are related if there exists a connected subspace of X containing -1 and 2 at the same times. -1 is in that thing and also 2 is in there. So observe that -1, 2 is not connected, subspace of X. It's not a connected subspace of this X, but actually that interval is a connected subspace of R, of a real line, but it's not a connected subspace of X defined in that way. So how many components are we having? We are having this as a component, also this as a component, so that as a component. Yeah, those are the connected subspaces of X in such a way that there exists no connected subspace of X containing them. They are the maximal connected subspaces of that X.